Hi, my name is Binhan Li, and I will introduce the multiple linear regression hash removal model based on dark channel prior, and time is limited, so I will introduce briefly. Many images with haze will affect the performance of many vision algorithms, so we want to improve the performance of a famous dehazing algorithm, dark channel prior, to overcome its weakness, and use the improved model on object detection in haze. It's the background of the Hessian algorithm. And from the principle of dark channel prior, we can get equation 3. And use equation 3, we can estimate medium transmission by equation 4. I also studied many object detection model, and each model in the list improved a lot based on the previous one. And recently, the domain adaptive mass RCN gets the highest MAP value in object detection in haze experiment. One limitation of dark channel prior is the rough estimation of medium transmission. It can cause the brightness of the restored image darker, and these darker parts may affect the precision of object detection in haze. Another limitation is the rough estimation of atmospheric light. It can cause the color distortion and shift in the bright region, especially in the sky. And in the formation of a clean image, we add 3 weights to each independent variable and a bias to form a multiple linear regression model. And we will use the realistic single image dehazing dataset to train the model, and use the synthesized object testing site to test the performance of the Hessian algorithm. And we will also use original dark channel prior and improved dark channel prior model to dehaze RTTS dataset first, and then use the dehazed image dataset to test the object detection model. In the training part, we define the loss function by mean squared error. We implement the stochastic gradient descent algorithm to minimize the loss function, update the weights and bias by equation 9 and equation 10. Recite dataset also provides evaluation criteria to compare dehazing algorithms. We use SSIM and PSNR as the dehazing criteria, and use the MAP to measure the performance of object detection. From the dehazing experiment results, we can see our improved model gets the highest SIM value, and its PSNR value is also among top 4. And from restored image by our model compared with the ground truth image, they are very similar. And we also want to prove our improved model can not only perform good on dehazing synthetic images, it can also perform good on dehazing real-world haze images. And when test on the object detection in haze, we use the domain adaptive mass RCN model, and combined with our dehazing model, it can get the MAP value just 0.1% lower than the previous highest value. So we conclude that our improved model gets the highest SIM value and reasonable PSNR value, and also perform good on dehazing real-world hazard images, and gets almost the highest MAP value when combined with DMAX RCN model. So overall, our model is the highest dehazing algorithm so far. And we also get an assumption that a higher PSNR value and ISM value do not equal to higher MAP value on object detection in haze. We want to study what kind of quality of a dehazed image can get the highest precision of object detection in haze. That's all. Thank you.